Alright, first we'll start by drawing the structure. To start drawing the structure, we're going to start with a heptane chain. So 1, 2, 3, 4, 5, 6, 7. Now that we have our heptane chain, we're going to draw our 3 ethyls, so we're going to go to our 3rd carbon. We decided to start from the left arbitrarily. So 1, 2, 3. So on this 3rd carbon here, we're going to draw an ethyl group. So there's that 2 carbon chain. On the 2nd carbon, so 1, 2, we're going to draw a methyl group. So just add 1 carbon to that group. And then we're going to go to our 4th carbon, 1, 2, 3, 4. We'll draw a methyl group on each side of that carbon. So it looks something like that. So since this molecule can twist and turn in shape, we don't have, when we're first drawing the most stable structure, we don't have to worry about the drawing in terms of what's popping up at us, going to our left or to our right. So when we're drawing the most stable, we want one with the least amount of reaction or interactions with each other. So we're going to pick something that's staggered, and where our biggest groups are on the opposite sides. So first we're going to draw that front carbon.
Can we explain it differently?
Can I explain it to someone face to face?
So on that front carbon, our biggest group is going to be the isopropyl group, which is this group here. So the isopropyl group is going to, we'll just put up here. I'm just going to label it like that. That's the isopropyl group. Next, we see that another thing added to this carbon, the next biggest chain here, is going to be this ethyl group. So I'll put that here, label it ethyl. And then the smallest thing we have on this is that hydrogen that would come out right here, but we don't see because it's implied in the molecule. So we'll put that right here. So now we're looking at the back. Since we want, right now we want the most stable structure, we want the biggest part of the molecule to be on the opposite side of isopropyl. So in deciding what that's going to be, which we're going to place right here, we're going to pick the largest part. So that's going to be this propyl group, this 3 carbon group on the end here. So I'm going to label that PROP, per propyl. So then when deciding what's going to go next, we got to look at its other 2 groups. We see that both these groups are the same. They're both this 1 carbon methyl group. So we can put those on each side here, which I'm going to label Me for methyl. So this should be our most stable interaction because there's the biggest carbons on the end are farthest away from each other, so they're going to interact the least amount with each other. So this is going to cost the least amount of energy and therefore be the most stable. So now we're going to rotate this in order to make our least stable. So when thinking about our least stable, we're going to think of it in terms of the opposite of what we just made. We want where there's the most interactions. So we're going to want when our 2 biggest groups are interacting the most with each other. So we're going to look at something that is eclipsed. So we're going to draw, I prefer to rotate our back molecule. So I'm going to keep the front one the same. This isopropyl group here, ethyl group here, this hydrogen group here. So what we're going to do is rotate this 180 degrees, essentially, so that our propyl group is here. Our ethyl group is going to be rotated 180 degrees here, and our oh, sorry, that's a methyl group. My bad. Methyl group's there, and then our other methyl group is here. This interaction should create the most amount of energy and therefore be the least stable. So that's how you answer number 1.